Hello. Yes, we welcome you back. This is Physical Sciences Silver Bullet, PSSB, and it's Richard behind the channel. So we are looking at this question. It says standard solution, standard sodium carbonate solution is prepared in that volume, 250. So during titration, 25 of nitric acid with the concentration of 0.15 moles per cubic decimeter is neutralized by 25 of our standard solution. The reaction is given is between nitric acid and sodium carbonate, giving you these products. Then the question comes, it says, write the name and formula of the salt formed during reaction. So we have to know that this reaction is neutralization reaction. It's a reaction between an acid and a base. Okay, this happens to be our acid and this is our base. Now we have to recall that during neutralization, a salt is formed. Sometimes salt and water, sometimes salt, water, and carbon dioxide, but a salt has to be formed. And how do you identify a salt? A salt is a species which is having the positive part, usually metal, and the other part a radical or anion of any sort. So a salt is made up of a positive and negative ions. The positive is predominantly a metal. So what is the salt? This is our salt. What is the name? Sodium nitrate. What's the formula? The formula is there. So let us write it down. Okay, that is that. So let us go to the next question. Then comes this question. It says, calculate the mass of calcium carbonate used to prepare the standard solution in a volumetric flask. So there are several approaches on this question, but we are going to use the one which we feel is universal, and once you crack it, you'll be the master of these calculations. We are going to use a stoichiometry. What we do here, we divide our part into two. We can divide this space into two. One side, we can call it sodium. Okay, let us do it the same. One side, you can call it nitric acid. And the other side, sodium carbonate. Now, with this method, what do we do? You bring in the ratios. This side will have 2, and this side will have 1. Where do you get these numbers? We get them from here. This 2 is what we have put here, and then there's a 1 there which we have not written. It is here. So this side, what do? You check what you have. For nitric acid, they gave us the concentration. It is 0.15 0.15 moles per cubic decimeter. What else was given? They gave us the volume, which is 25. Converting it to cubic decimeters, you'll get 0.025 cubic decimeters. So with these two, what are you looking for? You are looking for N. With this method, you have to know that these are mole ratios, or our intention must be to get moles. So use this formula. The formula says C is equal to N over V. So when you use it, C is known. C is 0.15. N is wanted, but volume is known, is 0.025. So from here, you are going to get your N after cross multiplying as our. So that's that. These are the number of moles we have obtained from here. So what are these number of moles standing for? They are standing for the number of moles of nitric acid which reacted. Now you have to go this side. What do we know this side? We just know that the ratio is 2 to 1. And what are you going to calculate this side? We are going to calculate number of moles of sodium carbonate that reacted. We can call it X. So you have to remember that these are directly proportional ratios. Having this one and having this one and having this one can give us X through cross multiplying. So what are you going to do? We are going to multiply this one with this, and you're going to multiply this one with that, and this is what you get. You're going to get 2x is equal to 1 times 1 times 0,00375. So from there, what do we get? X is going to be 0,00375 divided by 2. So that's what you're going to see. So after cross multiplying, we get these ones as the number of moles. What are these moles representing? They are representing number of moles of sodium carbonate which reacted. You have to remember that these moles are contained in 25 cubic decimeter. So let us squeeze something here. Yes, this number of moles we have just calculated are the number of moles of sodium carbonate which reacted, and they are contained in 25 cubic decimeter. So in other words, this is what we know. We know that 25 cubic decimeter of the standard solution of sodium carbonate contains how many moles? Contains 0.00185. But you need to recall that our standard solution is not made up of 25. We prepared 250 And out of the 250, we took out 25. And what we want to calculate here is the mass of sodium carbonate, which was dissolved in 250. So it requires you to equate this one to 250. So in other words, if 25 contains that, 250 cubic centimeter of this will contain what? Let us call it X. These are direct proportional ratios, so you can cross multiply. And when you do that, you are going to get X as 250 times 0,001875 over 25. And what do we get as the answer? That's what we are going to calculate and get. So we get this. What we have here, these are the number of moles of sodium carbonate in 250. But the question wants mass. What do we do? Then we bring in our equation, which we know is number of moles is equal to mass over molar mass, and it's molar mass of sodium carbonate. So what are the number of moles? We'll have it here. It is 0.01875, and we are looking for mass. Then we have to calculate this, the molar mass of sodium carbonate. So that's what we have for the molar mass. So after cross multiplying, this is what we are going to get. You get mass as 0.01875 times, from here we have 106. And what we get here is going to be the mass which was dissolved. Then after computing with the calculator, we get this one to be our mass. So the mass which was initially dissolved in the 250 cubic decimeter volumetric flask was 1.99 grams. Okay, thanks very much. We thank you for subscribing, and we would urge you to comment and also to call others to the channel. Thanks very much.